been a problem I've been having at work on a horizontal boring machine. It's a older, early 1980s vintage Shibaura that in the early 1990s was converted to FANUC, I think OM control if I remember right, and then it also has for the axis drives it has a Servo Dynamics SD3060 system, which was probably originally came out like mid 1980s. Most of the date codes on the semiconductors on this unit is around 1990, so that puts it right about the right time frame that the machine was retrofitted. But I've had a problem with this thing. There was a pretty major disaster. I'm not going to get into it on the drive package. Had a motor burn up over a weekend when nobody was there, and some really bad things happened. Got all that straightened out, and I still can't get this machine to run. I keep taking out one of these rectifier fuses. So the natural progression here is to go to the three-phase bridge or the bus capacitors. So I pulled that apart. This, and I guess I should back up a little bit. This drive package runs off of 120 volt three-phase, 110 volt three-phase, whichever it is, and it comes out of a step-down transformer that connects directly to the line that runs to the machine. But this three-phase bridge is configured of single individual power diodes mounted on this kind of chintzy looking bracket with insulators and whatever. Then that's bolted to the case of the unit as somewhat of a heat sink. I had some pulled all these out individually and checked them for leakage on my Sencor LC101, and they all checked out really good. The worst leakage I had on any of them was, I think, 6.3 microamps, and actually that was kind of surprising to me. It may end up being a problem, but I doubt it, because I ran out to 300 volts and it didn't increase any. But ran into a problem with one of the Kapton insulators, which had failed. And if anybody knows much about Kapton, one of the reasons they've quit using Kapton on this sort of application is because it does eventually fail. But I replaced that with some Teflon washers and got everything isolated back to where they ought to be really well. And then I've got a 350 kilo ohm 10 watt resistor across the output of those that I think its main purpose is there to slowly drain the charge on these bus capacitors. You got two 5400 microfarad 200 volts in parallel, so that gives you approximately 10,800 microfarads, and then you get 160 volt DC that powers up each one of the drive boards on the actual power side. And they've got basically a PWM control that controls the voltage out to the motors. But the moment I fire this thing, flip the switch to turn the machine on, it takes the exact same fuse out each time, and I just can't seem to figure out why. I checked the bus capacitors also with my LC101 at the rated voltage for leakage, no problem there. And so I went back, started right at the beginning, completely disconnected the input lines, thinking, maybe I've got one burnt to ground somewhere I don't know about, can't see it. Doesn't take the fuse out. Eliminated everything from here and connected up just the three-phase bridge. Does not take the fuse out. Connected the 10 watt bleed capacitor, resistor. Does not take the fuse out. Connected one of these capacitors, does not take the fuse out. Connected the other capacitor, does not take the fuse out. Now I should back up and also say that this is completely isolated. It doesn't go to the other drive packages at the moment. I'm working my way to that. Connect both bus capacitors up and then have everything in this system from here to here. immediately takes the input fuse out. So I'm not sure what's going on here. I put an order in for an actual packaged 3-phase bridge rectifier and 2 more bus capacitors, just mainly because, you know, even though they test good, there's something there failing. I don't know what, but I started thinking about this. Of course, this drive package has been in here now, you know, close to 25 years. But normally you would have some sort of a current limiting resistor, so that when these bus capacitors initially start to charge, that high surge current doesn't take out these fuses. And this drive package doesn't have that. So I don't know if maybe it's a combination of starting to get a little bit of leakage in one of these, that one diode that I showed, and maybe these capacitors are a little bit leaky on initial startup, and that's what's taking out the fuse. I'm not sure. Whenever I do put this back together, I think I might investigate, maybe not necessarily a current limiting resistor, that's kind of old school, but maybe putting a PTC in line with this, that's with like a timing relay, where say for half a second the PTC is in line before it goes to the bus capacitor to limit the amount of current that these can be charged to, and then half a second later the timing relay jumps that out. It's going to have to, it might be kind of expensive though. It's going to be kind of have to be an awfully heavy contact, since this whole package is protected by a 40 amp fuse, so it's probably full tilt, it's probably pulling a good 30 amps, I would have to imagine, or has the potential to. But I don't know, I just thought that I would film this and kind of explain what's going on and show what's here. And I don't know if anybody watching any of my videos would have any ideas of what's going on here, if I'm on the right track, or maybe there's something I'm not seeing. But if you are, then get back with me and let me know what you think.